this form of the particular solution, y particular a times t times e to the negative t, my a is -1. Did everybody get -1 for a?
Yes.
Excellent, very good. So again, sometimes you run into an exceptional case, such as here. A particular solution that you originally tried doesn't work. When that happens, try multiplying your particular solution by t. And if this doesn't work, instead of t, try t squared. Okay, so any questions? Any questions? Let's try number 14. Okay, so this is our DE, and we have to find a solution of the associated homogeneous equation, then use the technique of this section to find a particular solution. Oh, and there is also, no, wait, just a moment. I'm sorry, I was reading the wrong problem. Use the technique shown earlier to find a particular solution for the given DE. So we are looking for y particular. Okay, so let's find y particular for this particular differential equation. So what is this, what kind of forcing term do we have here? What is this function? What do we call it?
Linear?
That's right, it's a linear polynomial. Excellent, linear polynomial. So when you differentiate a polynomial, you get a polynomial. Therefore, we will be looking for y particular in the form at plus b, which is a linear polynomial. So let's see if it works. Let's take derivative. Very nice. Derivative is just constant a, and the second derivative is 0. Very convenient. So I'm going to substitute all of these. So we have 0 plus 5 times a plus 4 times at plus b equals 2 plus 3t. So this will be 5a plus 4at plus 4b equals 2 plus 3t. So we're going to consider all constants on the left and right, and also all terms that involve t. So the first equation will be 5a plus 4b equals 2. And the second equation will be 4a equals 3. So we equated like terms on the left and right hand side. Do you agree so far?
Yes.
Okay, very good. Feel free to ask. If there are questions, feel free to ask. So we can find a right away. A is 3/4. And from there we can find b. So 4b is 2 minus 5a. So I substitute 3/4. This is going to be 15/4. Let's see, b is, let me first combine these two. So 4b equals, this is 8/4 minus 15/4. So I'm getting -7/4 on the right-hand side. Divide by 4 both sides, I'm getting -7/16. So we're ready to say our particular solution equals 3/4 times t minus 7/16. So this is what I got here. And please let me know, are you getting the same? Do you agree with this?
Yes.
Excellent, thank you. All right, so we have our particular solution. However, this problem was even, right? Even problem means I cannot check with the back of the book. So that's why I'm thinking I should probably make sure to check my final answer. So I'm going to take derivative. I'm getting 3/4. I'm getting y prime double prime, y sub p double prime equals 0. And I'm going to plug that in here just to make sure everything is fine. So 5/3, 4 times so I want to make sure I'm getting two statements. So 2 plus 3 times t. So this is 15/4 plus 3t minus 7/4. And I want to make sure this is the same as the right-hand side. Yeah, 3t, but what about this? So 15 minus 7 is 8, right? So 8/4, 2. So 2 plus 3t. Yes, 2 plus 3t. So yes, looks fine. Are there any questions, number 14? All right, so let us now discuss the second method. So I said that we will have two methods for solving this type of equations. So the first method that we discussed was the method of undetermined coefficients. The second one is called variation of parameters. So now we will do 4.6 variation of parameters. Variation of parameters. And this method should sound familiar. We had this method when we solved linear differential equations. We're still working on linear. These are linear second order inhomogeneous, right? Problems. But the key word is linear. These are still linear, okay? So we're still going to consider the same type of equations. Let's start with writing this down. Inhomogeneous, right? And P and Q here are, well, we're going to work with constants. So most of the problems in these sections, most of the problems will have P of t and Q of t equal to constants, okay? So we'll focus on that. Those are simpler, more simple. All right, so for this method, we will start with an example. So example, here is the problem, y double prime plus y equals tangent of t. So is this equation linear?
No,
Why not?
I'm not sure if the tangent of t would affect it.
Yeah, tangent is a problem. However, because it has t, not y, it's still linear. So your function, yeah, g of t, so this is your g of t, right? And it could be any function, including nonlinear, right? So g of t could be nonlinear function of t. The equation is still linear because second derivative of y and y appear in linear fashion. So this is still linear in terms of y. So this is linear and inhomogeneous, right? Inhomogeneous. Some books call it non-homogeneous, so it doesn't matter. It's still the same meaning. On your quiz number 4, which will be open today, it's ready. I just want to test it to make sure that there's nothing wrong in there. So in quiz number 4, you will have to determine if equation is linear or non-linear. So this is a good exercise right now, is to look at this equation and observe that this one is linear because y prime and y double prime appear in linear fashion. So yes, tangent is okay because this is tangent of t, not tangent of y. If it was tangent of y, then equation is nonlinear. Do you agree? All right, so we will start with homogeneous problem. So start with the homogeneous. Start by solving homogeneous problem. In other words, ignore for some time this tangent, pretend that your equation is homogeneous, and solve the characteristic equation. So this is the characteristic equation. We have lambda squared plus 1 equals 0. And it looks like we're getting complex conjugates. Am I correct?
Yes.
Excellent. The real part is 0. We're only getting plus minus I, and that implies our solution y of t, the general solution, is a linear combination of the fundamental solutions. So it's C sub 1 sine. Actually, let's start with cosine. We usually say cosine, right? C sub 1 cosine and then C sub 2 sine of t. So I'm going to clear that. So we will have cosine of t plus C sub 2 sine of t. So are there any questions so far regarding this general solution of homogeneous problem? All right, so next step is to replace these two constants, C sub 1 and C sub 2, by functions of t. So we're going to say, instead of C sub 1, this is step number 2. Replace C sub 1 by, let's call it V sub 1 of t, and C sub 2 by V sub 2 of t. So now instead of constants C sub 1 and C sub 2, we're going to write y of t equals V sub 1 of t times cosine of t plus V sub 2 of t times sine of t. Any questions? Again, this method has been discussed in the beginning of this course when we talked about linear differential equations. So again, replace the constants of integration, those constants C sub 1, C sub 2, by functions. That's all we have to do. So next step will be to take derivatives. We're going to differentiate this y of t. We're going to treat it as a particular solution. Let's call it y sub p. I'm going to call it y sub p according to the text. So we'll find the derivative using the product rule, right? Because this is now a function of t. It's not just a constant. So v sub 1 prime times cosine minus v sub 1 times sine of t and plus v sub 2 prime sine of t plus v sub 2 cosine of t. Do you agree with this derivative?
Yes.
Excellent. We still need to differentiate one more time so that we have y double prime. So let's, unfortunately, it's going to be more tedious because we have 4 terms and each one requires to use the product rule, right? So it's going to be tedious. Well, let's hope that we can cancel. Well, actually, let me see if we can cancel anything here. No, nothing can be canceled at this point. So let's proceed to the next step. So we will have y sub 1 double prime cosine t minus v sub 1 prime times sine of t. Then we have minus v sub 1 prime sine of t minus v sub 1 cosine of t plus v sub 2 double prime sine of t plus v sub 2 prime cosine of t, v sub 2 prime cosine of t, and one more, minus v sub 2 sine of t. Do you agree with this? Yeah?
For tangent, why are we doing cosine and sine? Shouldn't it be secant squared that we're dealing with for the derivative?
No, this is a different method. This is a different method. So this method is called variation of parameters. And in this method, we are not going to even look at this right-hand side until much later. So one more time, in this method, our first step is to solve the homogeneous problem and then replace those two constants by v sub 1 of t and v sub 2 of t. So we're not even looking here right now. We're not even going to worry about tangent at this point. So we will worry about this a little later. So at this point, we just need to substitute everything into the differential equation. So does everybody agree with this so far, the derivatives?
Yeah.
So one more time, this method is called variation of parameters. Variation of parameters. So this method is different from the one we used earlier. Unfortunately, it's a little messy. So again, this is variation of parameters, and it works different. It works different. So again, we start by solving homogeneous problem. So we're not even paying any attention to this tangent. Replace tangent by 0 and solve it as if we just have homogeneous problem. Once you got the general solution, replace c sub 1 and c sub 2 by functions v sub 1 of t and v sub 2 of t. And then differentiate your y sub p twice and plug everything back into the original inhomogeneous problem, okay? We have to plug that into the inhomogeneous problem.
But where did you get the sine and cosine from?
Those are from section 4.3. This comes from section 4.3. Once you found your characteristic numbers, they are complex. So if that happens, if you have complex characteristic numbers, your general solution will be linear combination of sine and cosine. This is something we discussed in section 4.3. So if you have complex characteristic numbers, you get, let me use this paper here as a scratch. So again, we said that if you have two complex characteristic numbers, then the corresponding general solution will be in the form e to the at times c sub 1 cosine of bt plus c sub 2 sine of bt. So again, this was from section 4.3 when we discussed simple harmonic, well, yeah, it was method for solving homogeneous, linear homogeneous differential equations. Okay, so this is where we get this general solution. And keep in mind that a in our problem, a is 0. The real part of your characteristic number is 0, so e to the 0 is 1. So that's why we end up with just this part. B is equal to 1, right? So B is 1, A is 0. Any questions? All right, so let's examine second derivative. Can we cancel anything? We're supposed to cancel a couple of terms. Can you tell me which terms to cancel? Actually, we can combine some terms. Am I right?
Yeah.
Let me see. Yeah, so let's do that. Which terms? I see this one and this one can be combined. And what else? Can we cancel? Let's see. Something else should be combined here. Let me see. Oh, these two, am I correct?
Yes.
All right, let's do that. So v sub 1 double prime cosine t. Then we combine these two, so minus 2 v sub 1 prime sine of t. Let's see, what else? Minus v sub 1 cosine t plus v sub 2 double prime sine t, and then plus 2 v sub 2 prime cosine t minus v sub 2 sine t. Well, so this is the second derivative, and we're ready to substitute everything back into the inhomogeneous equation. So step number 3, substitute y sub p prime, and y sub p double prime into the inhomogeneous equation. So finally, we are returning back to the inhomogeneous problem. Now we will have to deal with the tangent. We will have to deal with that. So let me do this here because I'm probably going to run out of space. So I'm going to substitute y double prime, all of that. Unfortunately, it's pretty tedious. However, there is a shortcut that we will discuss in a few moments. You don't have to do all of these every single time you use this method. So this is just the second derivative. Then you have to add y. So my y is over here. So I'm adding v sub 1 cosine t plus v sub 2 sine t. And on the right-hand side, we have our tangent of t, okay? Are there any questions? Any questions? Is there anything that we can cancel? Is there anything that we can cancel?
V sub 1 and V sub 1 plus cosine? Or
Yeah, excellent. I think these two, am I right?
yeah.
Anything else?
V sub
yes.
2 sine.
Excellent. Do you remember the variation of parameters method? We must be able to cancel something. There has to be some cancellation. If it doesn't happen, something is wrong. That was, again, in section 2.4 when we talked about linear differential equations of first order. So again, something has to cancel out. So what's left? Let's see. V sub 1 double prime cosine t minus 2 V sub 1 prime sine t. Then we have plus V sub 2 double prime sine t plus 2 V sub 2 prime cosine t. And on the right-hand side, we have our tangent, right? We have our tangent. So next, we will have to equate. So, well, first of all, tangent is not a very convenient function here. So yes, we will combine so I'm trying to compare to make sure I'm getting the same result as in the textbook to make sure I didn't make any mistakes. So so the textbook has y double prime. Let me check again the second derivative. The second derivative, v sub 1 they don't have any of these terms here. V double prime cosine, V double prime sine. So all these terms are actually not present in the second derivative. So let me so again, I'm looking here. So first derivative, first derivative is, let me see. First derivative, they have only this term and this term. The other, oh, okay, I see now. Okay, so there's some assumption we have to make here. They impose additional constraint on the functions v sub 1 and v sub 2. So they set expression containing first derivatives. So this one right here and this one. So they set those two equal to 0. The sum of those two terms equal to 0. So this is to simplify computations. Well, that makes sense. So one more time, they set v sub 1 prime cosine t plus v sub 2 prime sine t equal to 0. These entire two terms together, the sum is 0. So if you do that, then many of the terms you have here will be gone. So let us make some correction here to make life easier. So this is page number 12. So let me perhaps add over here. these two terms are zeros. Set v sub 1 prime cosine t plus v sub 2 prime sine t equals to 0. Yes, this will make life easier. One of those constraints that will save us a lot of time. So if that's the case, then our second derivative is going to only contain 4 terms. Am I right? Second derivative. So this term will be gone. So v sub 1 double prime is gone. We will have, yeah, unfortunately, I'll have to redo this page because it's just too many corrections here. If you're copying this work, please cross out, probably starting from here. Cross out starting from here. So I'm going to call the next page number 12 because I'm going to throw out these 2 pages. It's just going to be too messy if I start crossing out the terms. So y sub p prime is, we said v sub 1 prime cosine t minus v sub 1 sine t plus v sub 2 prime sine t plus v sub 2 cosine t. So again, the book says regarding this method that it's easier for us to set these 2 terms together equal to 0. So again, we will set v sub 1 prime cosine t plus v sub 2 prime sine t equal to 0. Well, that makes our life much easier because second derivative will be shorter. So negative v sub 1 prime sine t minus v sub 1 cosine t, and then plus v sub 2 prime cosine t and minus v sub 2 sine t. Do you agree with this so far? So again, I had to throw out the previous 2 pages, numbers 12 and 13, because we had to use this constraint right here. So this is an important constraint which we need to highlight or box it because this is something very important. We will have to use this later. So y sub p double prime doesn't involve any second derivative anymore. All right, so now let's plug that into the inhomogeneous equation, and life is much easier now. So we have negative v sub 1 prime sine t minus v sub 1 cosine t plus v sub 2 prime cosine t and minus v sub 2 sine t. That's just the second derivative plus y, v sub 1 cosine t plus v sub 2 sine t equals tangent. So this is the inhomogeneous problem. This is step number 3 when we return to the inhomogeneous equation. All right, so this cancels out, right? And this. So we have a couple of cancellations here as expected. So we get minus v sub 1 prime sine t plus v sub 2 prime cosine t equals tangent t. All right, finally, life is so much easier this way. So on your index card, you will need to put a couple of equations for this method. So the first equation will come from here, and the second will come from here. So let me write that down on number 13. Number 13, we say in general, use the following. Use the following system to find v sub 1 and v sub 2. The first equation will be v sub 1 prime y sub 1 prime plus v sub 2 prime y sub 2 prime equals g of t. This is the one we have here. And the second one will be this one, v sub 1 prime y sub 1 plus v sub 2 prime y sub 2 equals 0. So this is the general system to use. You don't have to go through all the details. Just write this down on the index card and use it. So here, again, v sub 1 and v sub 2, those are the functions we use when we replace c sub 1 and c sub 2 by v sub 1 of t and v sub 2 of t. And y sub 1, y sub 2, those are your fundamental solutions. This is y sub 1, this is y sub 2. All right, so any questions? So yeah, we're getting close to the end of this lecture. So let us start with this one, v sub 1, let's see, v sub 1 prime cosine t plus v sub 2 prime sine t equals to 0, okay? So we can multiply both sides by sine of t. So if you do that, you will get, let me write them down one underneath the other. So minus v sub 1 prime sine of t plus v sub 2 prime cosine of t equals tangent of t. So this is the system that we need to solve now. So to solve it, the text suggests to multiply both sides of this equation by sine and both sides of this equation by cosine, and then add them together to eliminate the first term. So you get v sub 1 prime cosine t times sine t, v sub 2 prime sine squared t equals 0. So I multiplied again by sine of t, both sides of this equation. And the second equation, multiply both sides by cosine. So you get minus v sub 1 prime sine of t times cosine of t plus v sub 2 prime cosine squared t. And then tangent is sine over cosine, so cosine cancels out. We get just sine of t. Okay. So we add them and cancel these two terms. So we get v sub 2 prime sine squared of t plus cosine squared of t. And on the right-hand side, we get sine of t. So this is 1 inside parentheses, and we are ready to find v sub 2. So v sub 2 equals integral of sine of t dt. And we have integral of sine is negative cosine of t. Once you have your v sub 2 of t, we're ready to find I'm sorry, this was v sub 1 or v sub 2? Oh yes, v sub 2, right? So we just found v sub 2. Let's find v sub 1 now. So v sub 1 can be found from this first equation right here. So v sub 1 prime, I'm using actually this one, v sub 1 prime cosine of t plus v sub 2 prime sine of t equals to 0. So we already know v sub 2 and we know the derivative, so we can write v sub 1 prime cosine t plus, instead of v sub 2 prime, I write sine of t times sine of t equals 0. So v sub 2 prime is sine. So v sub 1 prime cosine t plus sine squared t equals 0. And v sub 1 prime equals negative sine squared over cosine of t, right? So now you're ready to integrate this equation, both sides. Negative integral sine squared t over cosine t dt. Okay, so we found v sub 2 already, so now we just have to find v sub 1. We have to integrate this expression. So you could, this is one of the formulas. Let's see. So sine times tangent. So v sub 1 equals negative integral. This is sine of t times sine of t over cosine of t dt. So v sub 1 negative integral sine of t times tangent t dt. So we can use one of the formulas of integration to find this. So we have ln v sub 1 equals negative ln absolute value secant t plus tangent t plus sine of t plus constant of integration, but we're not going to worry about that right now. So once you have v sub 1 and v sub 2, you're ready to write your final answer. So y particular, so we return back to the homogeneous. This is our general solution. So all you have to do is plug in v sub 1 instead of c sub 1 and v sub 2 instead of c sub 2. So instead of c sub 1, we have negative ln absolute value secant t plus tangent t plus sine of t times cosine of t. That's just the first term. I replace c sub 1 by v sub 1. And finally plus c sub 2, which would be this one, v sub 2. So it's over here, negative cosine t times sine of t. So yeah, that looks pretty tedious. So this is the particular solution for our inhomogeneous problem right here that involves tangent on the right-hand side. So this cannot be solved using the undetermined coefficients, or at least it would be very difficult to do that. Do you agree? So this is the method to use in this problem. So any questions? So yes, this one maybe not the best example. It's a good example because you cannot really solve this using the undetermined coefficients with this tangent here. So this example shows that this method is the only one to use in this particular situation. However, the method itself is a little tedious for this problem. So again, any questions? So let me give you a few problems to practice with at home. So this is homework section 4.6. So let's try these numbers. 1 through 9 odds. 9 through 9 odds. So I don't plan to have any new material on Tuesday. I plan to review, so I will answer any questions regarding your homework first, so please make sure to ask. And then I will review the material quizzes, the last probably couple of quizzes, or any other quizzes that you would like to discuss. Any questions? So we only have, let me check. So today is the 28th. We have regular lecture on the 2nd. So it will be review and again, bring your questions to class. And finally, there will be midterm on the 4th. So midterm, just like the first midterm, I will proctor using Zoom. And after that, we only meet for the final examination on the 11th. Are there any questions? All right, so I apologize for taking